Audible, sir.
Sorry. Uh, am I audible? Yeah, sure. Just give me a second. Let me thank you for the introduction. Uh, just give me a second. Let me share my screen. Is my screen visible? Am I visible? Is my screen visible? Yeah, sure. Just give me yeah. I would like to thank the Minister of Management for this opportunity. I would like to thank Mr. Srinivas for the chairman, and I would like to thank Dr. G. Kanakadurga Garu, principal, and HOD of Automobile Department, Dr. G. Srinivas Sharma Garu, for this opportunity. And thank you, Vijay. Thank you for that. And let's start. I'm from EDS Technologies, and about EDS Technologies. EDS Technologies is spread all across India. It has 7 locations, and we have more than 200 associates, and we have more than 1,500 customers. So yeah, we provide various business solutions, engineering solutions, learning solutions, and services. And when it comes to engineering solutions, we provide PLM services like, and we are platinum partner with Dassault systems like 3D Experience, CATIA, Similia, Delvia, Innovia, ANSYS and QChecker. And if you go to mining, we also provide mining solutions and visual simulation solutions for the defense systems, where you can do mock warfare analysis or something like that. And we have GI solutions, hard GI solutions, and we have electronic design automation for electronic design automation solutions as well. And also we provide 3D printing solutions. Okay. And we also have the EDST. It's a baby product from EDS services, EDST e-learning, where you can where there are more than 135 CAD and domain-based courses. It will be useful for developing your skills, from college to, if you're moving from college to, to the industry. And with so many strategic partners, we have strategic partners with Dassault Systems, Technica, and Human Solutions, EOS, MAC, and ESRA India, and Festo and Synopsys. These are all customers. You can see various customers across all the industries. In transport industry, we have customers from Mahindra Rise, Maruti Suzuki, Ather, Exide. Not only automotive industry as in such, we also recently connected with the EV industry like Ather, and we have industrial equipments like Havel, Legend, and Synopsys, and government defense like DRDO, BHEL, ISRO, CSIR, and NGRI. And in aerospace, Dassault Systems is being used by Airbus and Magnum. And in academia, we are associated with most of the IITs and NITs and in college academics like MVSR. And let's start with a brief introduction to our portfolio and similar products. Okay, so just okay. So what is Simulate? Simulate is a Dassault System brand for realistic simulation, which helps the product. It's a Simulate is a portfolio, and it helps the product development for engineering organizations to achieve its technical and business objective. And products range from unified finite element solutions to automated simulation process engine to streamline the engineering and design flow. Similarly, ABAQUS also provides an upgrade path for ABAQUS simulations. Users who encountered like advanced topic, like advanced non-linear applications, and also it can be used for life sciences, manufacturing, and automotive industry. So here you can see what is realistic simulation, right? If you can see, what is realistic simulation? Realistic simulation what do you mean by realistic simulation? Okay, realistic simulation is a simulation that helps physical, realistic, and lifelike in every way. So what does that mean? So Simulate has worked closely with closely while developing the Simulia. So it has worked closely with the labs and testing labs, so that you can write the code accordingly. And you can see in the first slide here in the slide, in the first one here you can see how while you're crushing the ground, you can see exactly all the crimps. It can be seen in Simulate also the product. And if you're doing crash analysis, you can use side load analysis. It's same courtesy to BMW with this system. You can see the same can be replicated with the finite element analysis using the Simulate products like ABAQUS. And the bird striking a wing plane, bird striking a plane, and you can see the testing of a BAW engine here. Now, so how can I improve my, what is realistic simulation? Tell me. Simulation helps you to improve the product design and development. It can be used at various stages, not only during the product development, even after the development of the product. Like if you're doing, if there are like most of the OEMs, right? So after the product development, there could be an issue with the issue after delivering the product. There might be breakage of the part, and you have to quickly rectify those. And at that stage, you cannot go to the lab and keep testing. You might need solution faster. For that process, you can similar use ABAQUS product, similar products, or finite element packages. So what do, what happens is, for everything you can't just go and do prototyping at each and every part in the design process, and it would take a long time. To reduce the time, you use a simulation technique. To reduce that, use a simulation product. And not only that, you can do various analysis, like you can do a drop test, you can do, for if you have products ranging industrial products like washing machine, or even your mobile phone if you're using it nuclear. And these are done various testing before releasing into the market. So these tests, now most of the companies do not do all the tests physically. So these are done using simulations. Okay, these are done, they're doing finite element analysis, and to reduce the time. So if you are doing a simulate every test, physical prototyping testing, everything, it takes a lot of cost to do the prototyping. And also you have to do multiple testings. To do the testing, the cost will increase, and the amount of time required to do this process also increases. To reduce this timing, we use realistic simulation. So what happens is, so you're doing a drop test analysis. So in the previous slide, if you go to, here you can see what do you mean realistic simulation. Here you can see can be crushed. Okay, so for the design process, you have to apply when the can is getting transported, or we have to see the what load cases it can take, what are the loads it can take. And similarly, with the BOW of a car, you can see that here in this, it goes under various testing. So for each test, you cannot do have a prototype for that. For that, you use simulations. Okay, and then. So our product portfolio addresses the need for this. Our similar product portfolio addresses needs for product development in a life cycle, from concept to detailed design and realistic simulation of complex physics. So what are the industries using realistic simulations? I told you before. All of them, all of the industries, from starting from automotive engineering. So in automotive industry, you can see they use it for various, from safety design to NVH, durability, powertrain, chassis, suspension, tires, and handling. And similarly, in the aerospace, using composites, composite analysis, and thermal fluid analysis, and impact analysis. And if you go to similar in ship industry, structure analysis, and stiffness, and wave slam, and nuclear blast analysis. And if you go into heavy machinery, evacuators, tractors, in all these industries, durability testing of these products, and various turbines, all these products can be done with simulation. Even for products that you're using in the day-to-day life, like your smartphones and telecom, you can, for the electromagnetic analysis are done for the to see the coverage of the antenna coverage, and where CST simulations are done, can be done using the products, similar products. And similarly, if you're having simple products for packing, if you, as I said before, you have so many products being delivered to you nowadays. So these products, so you can see they come in a package, right? So you have thermocol packaging that it comes with your packing. So even that packing is being tested. So when the product is set up, it can be tested using a finite element. So we drop along with the package and see if it's sustaining, it is protecting the package inside, inside the powder. And even in the life sciences, so designing of human tissue and using like creating stunts. Stunt analysis can be done using these softwares. Okay, if you go to as we are trying to approach to greener solutions, we are moving towards and seeing we are trying to use wind energy. And if you're setting up a wind turbine, you can do the structural analysis for that. So if you go structural analysis and or frequency analysis. Okay, and in the construction site, so for the building, if you're constructing a building, you need to check for the structural integrity of the building. So this can be done with the powerful solutions. simulation solutions that provided by the Simulia. So not only the industries are using them, even in the academic researching side, the Simula is very helpful for the researchers who are doing the PhDs or in the research. It's very helpful for them to so that they can be they can do all the simulations required for the development that are doing, and also in the mining industry. And so with the mining industry, Similia has products that help how to do the mining in the best way. And Similia has so many customers, and we are associated with so many, as previously told before. And these are a few of the customers, and we are partnered with PepsiCo, as you can PepsiCo, Alstom, HCL, Rolls-Royce, and Boeing. So there are two aspects in this product that we supplied by Similia. One is for commercial and one is for academic. So for commercial purpose, it is completely useful from starting from design stage, where the designers can like CAT your products and PLM services, design the product, and then design engineer can perform the you can go to design engineer, and then simulations can be done, and then researchers can use it with full-fledged node count. Am I audible? Can you hear me? Am I going too fast at this? Yeah, am I going too fast or too slow? You can just let me know. Yeah, sure. So in the AD step. So not from these are not only for commercial, as I told you before. It can be used for evaluation purpose and academics, for students and for researchers as well. And then so Simula, because Simula has a very powerful portfolio. It comes with ABAQUS, ISAT, TOSCA, and FE3A. So it's a complete package. Simula ABAQUS is a virtual prototyping solution based on implicit and explicit finite element analysis and simulation technology. The solvers are commonly used to have developed the competitive products at low cost to simulate the real world linear, non-linear applications. And these can also be found in various industries like life sciences, as I said before, and consumer products, electronics, and all other industries. And if you go to Simula, ISAT expands the benefits of simulation by incorporating the process flow modeling and optimization into product development. ISAT is a solver diagnostics and can integrate with existing in-house programs like third-party solutions, like if you have the CAD programming that can be integrated into this. And the benefit of ISAT is simulation automation and the process of integration and design optimization. And if you come to TOSCA, TOSCA is a non-parametric design optimization technique used for development. Like if you have a product and you want to reduce the weight and you want to see by reducing the weight of the product will take what can the design, if you can take a blank and you can use the TOSCA and give the parameters. Giving some parameters, you can get the structure that can be, which is very low in weight and which is very light and which can sustain the stresses, the loads that you are applying. So it's CAD-based geometry based on a non-parametric solution. Okay, and similar FE3A. So for FE3A is for doing static analysis and durability prediction. Like if you're having a component, it will be going so many cycles, like like the engine block and the piston rods in the engine block, they will be going for the same cycle again and again and different cycles through the life cycle. So to do those to simulate those analysis, we use FE3A. So this is an overview of the similar portfolio products, and let's start with the ABAQUS. ABAQUS is a leading technology for finite element analysis. It's a software used around in all industries, and its most powerful complete solution For engineering problems. It can do linear, non-linear problems. You can do implicit and explicit dynamic kind of sense. You can do crash analysis, and it is very robust in contact and started because the core software is run with the started with the contact analysis. It's very robust with the contact analysis and with a fracture. What do you mean by fracture? Like you can do fracture analysis, crack propagation, can be done using the similar product ABAQUS, and then composite simulations can be done for the various products, various composites that you're working on, and co-simulation. So linear and both implicit and explicit can be done together. So here you can see it's a tool for all. So it's a one tool with all the analysis in it. So it has from designer, from starting at designing stage, you can do small designers in there and do starting linear analysis. You can do here. You can see there's snapshot analysis going on in these two fronts, and you can see that drop analysis can be done. You can slosh analysis of it using CST elements, and then you can see the tire analysis, how the tire performs at various soil conditions and various weather conditions. These simulations can be done, and energy dissipation can be seen here, and also we can like crash analysis. So ABAQUS simulations, it can do very simulations, basically linear to highly advanced non-linear multi-large assembly simulations. It's a tool that fits for everybody's need. Okay. Uh, you can really what everybody does. They start with a simple model and increase the complexity and the model size and the physics as it grows and confidence in the simulation results and increase their expertise. To and mostly important find the valid simulation. So how does it all fit together? Not only because also is very associated with other software, like you can have other interfaces like CAD interface. It has dedicated. You can have other SolidWorks if you're doing a part in SolidWorks. SolidWorks accessory interfaces are there dedicated, so the third party CAD services can be included. So what does the associate interface do? So what is as you can see, if you model the product using a CAD software and that has been imported into ABAQUS, with this software interface, what we can do after doing analysis, and if you see, you can do small changes in the part, like a small component, and you do the analysis, you can see that if you want to decrease the thickness in the component, that would be automatically, if you do this, the changes in the ABAQUS, and they will be automatically integrated into the, CAD software. Similarly, if you do after getting the results, you are not expecting the CAD and you give the details to the CAD engineer. He does the changes instead of importing the model again. These changes done on the CAD will be directly integrated into the ABAQUS solution. Okay. As I spoken before, ABAQUS has solution for entire range of industries. So as I told you before, consumer packaged goods, plastic and glass forming, and automotive industry. Not only doing the chassis analysis, bending and torsion analysis on the chassis, body and tire analysis, and interiors like your IP boards and crash test analysis on the on BAW and the brake systems and doing thermal analysis on your powertrain and if you go to industrial equipment, you can do non-industrial analysis, you can do thermal analysis, very high cyclic loading, and life sciences like tissue modeling. I said before, you can do analysis on the stents, and if you go to high-tech industry, there you can do the thermal cyclic, solder on solder joints. That because the parts are very small, you can do this vibration analysis. You can do drop test on them, semiconductors, circuit board analysis, and you can do analysis on the antenna, how far the range of the antenna is going. Okay, all this. And if you go to aerospace and defense, same before you can do the fluid analysis. Uh, then landing gear analysis. And then if you go to structures, like you can do thermal, So natural frequency analysis, model analysis, you can do. Okay, you can see the structure to if the structure would fail if there's a fire, and you can do concrete analysis. Okay, these are the various analysis that can be done using it. Abacus. Now let's go forward. ABAQUS CAE. What is ABAQUS? Today, product simulation is often being performed by engineering groups using niche simulation tools from different vendors to simulate various design attributes. Uh, the use of multiple vendor software products create inefficiencies and increase costs. So Simulate develops a scalable suite of unified analysis of products that allows users, regardless of their simulation expertise or domain focus, to collaborate and seamlessly share the simulation data and approve methods without loss of information fidelity. And in the same case, the ABAQUS Unified FEA product suite, it offers more powerful and complete solution for both routine and sophisticated engineering problems, covering vast spectrum of industrial applications. Like I said before, in the industry, automotive industry, like what engineering working groups are able to consider full vehicle loads, like full vehicle loads and dynamic vibrations, and doing multi-body simulations, and also doing impact and crash. You can do nonlinear static analysis. You can do thermocoupling analysis, acoustic structural coupling analysis, and using a common model database structure and integrated software technology. And ABAQUS is the best-in-class companies are the best-in-class companies are taking advantage of this ABAQUS Unified FEA to consolidate processes and to reduce the cost of the product and reduce the inefficiencies and gain a competitive advantage over the competitors. So what? I'm sorry. Yeah. ABAQUS CAE. Let's have a simple overview on ABAQUS CAE. Can be used for both pre-processing the model, and then doing the analysis, and then doing the visualization. Okay, so what does it mean by pre-processing? In pre-processing, you can set up the load conditions. You can set the boundary conditions. You can check the model. If say if there are small changes in the CAD data that you got, you using the sketcher, you can change the scan data and set up a model using the pre-processing tool. And in the same because you have the analysis, and you can just submit a job and monitor the job. In analysis can be done in the same thing. And visualization, after getting the results, you can visualize the results, which is a post-processing. You can visualize the stresses that are coming out of the because due to the loads, the stresses, the displacements, and various graphs can be plotted. Okay, so these are the various modules and workflow that we go through in ABAQUS CAE. So we have the part model where you can create the parts and geometry and the features. We can decrease the radius, increase the radius of the circle. We can create parts. We can change the geometry. And then in the property definition, where you have to define the property of the component, material definition, and define the section, assign the section to the parts. And then we go to the assembly, where we position a part from initial configuration and set up the parts. And then we go to the steps, where you do what kind of analysis you're going to do. You're going to initialize the step from giving the what kind of analysis you're going to do, doing static analysis. You can do all that in the step. And then going to interaction, you can define the contacts and the constraints. Contact and constraints that can be done, like if you're doing a bonded contact or if you're doing a sliding contact. All this can be defined in the interaction section. And when we go to loads, here you can see you can manage the loads, how to apply the loads and boundary conditions using loads tab. And when we go to mesh, after creating loads and boundary condition, ABAQUS automatically does the meshing for you. So you can change what kind of element type you want. You can do a 3D tetrahedral element, or first order or second order. You can use the hex elements if the parts are simpler, and you can do 1D modeling, 1D modeling, 1D beam elements. Okay, and then you can create a job, and then you can create a job after doing the meshing. And then before submitting the job, you can do a data check, see if anything is missing. Sorry, just give me a second. And you can visualize the results after doing the analysis. Um, am I audible to everybody? Is it clear what I'm showing, and can you see the pictures? And yeah, hello. Yeah, sure, sure. So ABAQUS CAE has a very modern graphic user interface. It's modular and well organized. It's easy to use. You can change the you can customize it. The model tree, the customizable toolbars in this interface. So okay, in geometry and model import, you can with ABAQUS you can not only create the geometry, you can import CAD format, CAD geometry as step file or IGS files from CAD softwares where you can import the files. And after importing the files, you can see if there is small hatching, you can do small geometry repairs, because when you're importing small IGS files, there could be due to glitches, there could be it's not, and there could be some changes in the fillet areas that you can do, do change using the geometry model. So before even going into how to start ABAQUS, there are three ways of opening ABAQUS. One is through the command line, and this we will see. I will show all these while we're going through the workshop. Just to give a brief introduction, I'm going through these slides. Okay, so there are three ways of opening ABAQUS. You can open it from the command line, or you can open it from the menu bar, or you can, okay, and then working directory. From you can do go from the command line or open ABAQUS, okay, and then from go to the start menu, and you can see the ABAQUS. There you can see the ABAQUS file that you can open directly from there. You can go to the working directory and double click on the CAE file, and it will directly open the ABAQUS for you. So once you see how to open the file, then you can see how the geometry can be modified, or how the geometry can be imported. And ABAQUS is also very, robust in doing the meshing. So you don't have to, it doesn't not require any pre-processing. You can also import a mesh directly from if you're from other, if you don't write it as an MP file and import it. But ABAQUS has a robust, meshing process. So you can do, if you have if the components are small, you can do hex mesh on them. And you can also do, if your components are complex, like engine mounting, so engines and casting components, you can do the tet mesh, second order tetra mesh. Okay. And then not only that, you can extract from even from the mesh. Okay. So it can give semi-automatic hex meshes can be done through that. And it also has very powerful visualization tool. So after doing an analysis, you can visualize large models in that. So after doing analysis, you can do the displacements. You can how the product is. You can cut the product and see at each section how the product is behaving. Or by probing you can check the data at single point. And using plots, you can create the extra plots. You can create plots from the that are like over the time how the stress is varying. So this can be done using the ABAQUS visualization tool. So ABAQUS, see, that was a brief introduction of ABAQUS CAE, and While doing the workshop in the second half, we will be looking and we will do the workshop. I'll open Abacus, and you can work along with me. So Abacus has, as we spoke, analysis products. So Abacus has two things: basic standard and Abacus the Abacus standard and Abacus explicit for doing the analysis. So as you can see, Abacus standard employs a technology ideal for static and load speed dynamic events, where with high accurate stress solutions are critically important. And with this single solution, it is possible to analyze the model both in time and frequency domains. ABAQUS standard is supported with the ABAQUS CAE modeling environment for all the common pre-processing and post-processing needs. Here you can see if you can do a viscoelastic material like a rubber sealing, and you can do thermal coupling analysis like for brake analysis using thermocouple analysis. Example of a sealing pressure gasket joint you can see here, or you can do a steady state rolling of a tire, and you can do crack propagation of a airplane fuselage. So for example, one may start by performing a nonlinear engine cover mounting analysis. So this is a, you can see on your left hand side, this is a nonlinear and this is the engine cover mounting part. So for the gas where you can do the gasket mechanism. Okay, following the you can do the mounting analysis and pre-stress natural frequencies, and of the you can extract the piece if there is a gasket. So there's a gasket between your engine block and engine head, right? So and you connect them with the bolts and nut joints. So after you can do the gasket analysis previous from this pre-stress condition, and you can extract the natural frequencies, or you can do the stress analysis on that, or viscoelastic. Since the gasket, you can do viscoelastic analysis on that. Okay. And not only that, with the ABAQUS standard, you can also do mechanical and acoustic response of pre-stress. Like I said, if you can continue the same example of the engine block, pre-stress of the engine can be induced. Okay, vibrations can be determined. These all can be done with the ABAQUS standard. And the ability, if you go to ABAQUS explicit, it's also found human, and it is particularly well suited to simulate brief transient dynamic events. What do I mean by transient dynamic events? Like both are time dependent. It's not it's both analysis are time dependent. But the thing is, with the standard, what you can in standard we can do the analysis where the uh, load is applied over very small, very long time, and with explicit we can do the analysis like where the time is very short, like your drop analysis, or you can do drop analysis or crash analysis. These are all come under explicit analysis. So here there's one more thing. Though ABAQUS CAE supports like the results at any point with ABAQUS standard run can be used into the explicit, and vice versa. If after doing an explicit analysis, you can do you can do a standard the same model. Results can be input more into ABAQUS standard and do the analysis after that. So here you can see the results at any point with ABAQUS standard runs can be used as the starting condition for the continuation of ABAQUS explicit. So if you get results from ABAQUS standard, you can use it to continue the simulation, and you want to do drop tests. So like I said, if you have engine block, you can do normal analysis. You can do a stress analysis of uh, preload analysis, and then after that, using the those results can be used into doing an explicit analysis like creep analysis, using thermal creep analysis. Those results can be forwarded into doing explicit analysis. Okay. So ABAQUS standard it is based on an implicit solution technique intended for static and structural dynamic events. I can do both linear and non-linear behavior. So what do I mean by non-linear behavior? Here you can do there's basically three types of non-linearity behavior. There's geometric non-linearity, there's material non-linearity, and there's boundary condition. Um, so all these three can be performed using ABAQUS standard. So here you can see with the contact analysis, you can do snap fit analysis, or as I said before, gasket sealing analysis. You can do electric fuse, how it is heating over the time, and the tire noise to reduce. You can do acoustic simulations, to reduce the noise from the tire, and and you can do the stress analysis. Like here in the last frame here, you can see the frame. You can do stress analysis on bicycle frame. So ABAQUS standard implicit solution can be used for the static, structural, and dynamic events. And as I said before, ABAQUS explicit can be used. It's a time integration method, and it is intended for high-speed transient dynamic events. So it's also suitable for high-speed non-linear quasi-static analysis, like and so here you can see the bottle dropping and blow molding, deep drawing. This is deep drawing is a quasi-static analysis. So and over here you can see energy absorption or metal rolling, or when a blast you can simulate a blasting event. Also, we can do crash analysis. These are all come under explicit analysis. ABAQUS is a very accurate nonlinear solver. It's designed to handle models of any size, starting from a 1D beam element, and you can have full assembly model where your node count is more than 13 million or so. It's a very fast solving process. The process is you can use multiple processes at the same time and increase the speed of the process. And the algorithm is helps you to do the analysis very fast. It's very reliable and accurate. What do I mean? What does it mean by accurate? So it is very close to realistic simulation, as we've spoken before. Very all the results that you're getting are close to real world simulation. So as you can see here, this is courtesy to BMW. One of the pillars, and this is called B pillar, it's been crushed and it's been loaded from the side, and you can see, and when it is breaking, it's breaking at the same time at the loading. You can see that it's breaking in the same manner what's been done in the lab. So this is what we mean by reliable and accurate modeling. And when it comes to contact, ABAQUS is a ABAQUS has very ABAQUS has been a long leader in FEA, and also as it has very strong, sophisticated analysis can be done using this. It, as I told you before, ABAQUS can do both linear and non-linear analysis on the components and mechanisms. And when it comes to contact analysis, it's very robust and extremely robust. Can do various contact. The accuracy, there's a very high level of accuracy. You can do the contact. You can there a general contact and self contact can be done using ABAQUS contact user ABAQUS interface, contact interface. So you can have general. It has a general contact capability. Like here, you can see in this example, it's with folded. So when this product has been folded, it's come into contact with itself. So all this can be modeled using general contact. And if you're having various contacts can be analyzed, like tank contacts, sliding, small sliding, finer sliding. All these can be performed using a ABAQUS CAE. So here you can see the examples of how human feels it touching and where it is getting in contact. Similarly, you can use it if you're doing the tire analysis, you can do a contact where the tire is getting in contact with the road. These analyses can be performed. It can be contact with the road. These contacts can be created using the ABAQUS contacts. So ABAQUS has it does not have an material library as such, but it gives the feasibility to the customer, to create their own material model. Uh, Abacus material models can be, it has various material models. You can have metals, rubbers, and composites. You can include the linear properties and non-linear elastic and plasticity. Even material can be isotropic or anisotropic. It can be temperature dependent. Okay. And even materials like soils and rocks and concrete and ceramics can also be, all these material properties can be used, will be evaluated and can be done analysis using the ABAQUS CAE. And ABAQUS also has this various connections. So ABAQUS capabilities, when you talk about ABAQUS CAE, ABAQUS also has this connector, sampling of connection types to give various connections. Like if you're having a, so for example, if you see in top right, bottom right, here there's a shock absorber of a car. So you don't have to model everything. You can use you can simply use a connector for that, shock connector for that, and perform the analysis. And similarly, to do a flap mechanism, you can use the various joints available, and like in a hinge model, like if you're closing a door or opening a door, you can use hinge connectors there. So it has very robust elements and connection types. So do you have any doubts or clarifications so far? Okay. So when you see the capabilities, analysis capable, the advanced analysis capabilities. You can integrate both your stress data and your dynamic analysis data, and you can get the results. So what do I mean by that? So you can see a small rotor here, rotor blade. You can do you can get the stresses from that at your particular loading, and then you can get the do it normal dynamic analysis, simple static linear analysis to get the mode shapes, and then you can combine these results and view. So how the components behave if the components be stressed, and I want to know since this is a rotating body, I want to know the with that stress condition. I want to know the natural frequencies, so I can combine those and get the result. So and Abacus also has a very you can do damage and fracture analysis, like delamination model. And here to the right, you can see how you can do crack propagation. It's exactly you can see how it's been from the test sample, and after doing the simulation, you can see here on the left or top right, it's breaking in the same pattern. The pattern here is the same. So you can do various damage and fracture analysis, and you do multi-physics analysis like thermal analysis, or you can like you disc brake. So you at high speeds when you're braking, is a brake drum capable of handling that heat? If not only in road conditions, if you can these simulations can be done. These are highly used by Formula One cars. So because they're not only uh, if you take the breakdown of a break of a Formula car, it is very complicated. It's not a simple. They use composite materials on that, and you have to do the thermal analysis because it and that is at very high speeds. So these simulations can be done with the multi-physics capability of the abacus can be done. So as a summary, you can have what Abacus product is. Hope you got a basic understanding on what I wanted to get you an understanding of how the Abacus CA is, what is the, and then what kind of analysis can be done using an Abacus analysis product. So Abacus to give a small number, it can be used for realistic simulation, and it's been used by all the industries. It can do linear and non-linear behavior. It can do sophisticated contacts and material modeling. You can do very large models. And when it comes to ABAQUS, it is not only a precursor, it can be used for post-processing and doing the analysis as well. And ABAQUS is very useful, and it's a GUI is very simple. User can be adapted to it very quickly. It can be integrated with CAD softwares, and you can customize the GUI as you want. So this is a great tool to have to do the simulations. Okay. Shall we take a break of 5 minutes, or shall we continue? Yeah. Okay. So in the today's session, we're about to talk about. I'm sorry. Just give me a second. And so since we're going to have 2 sessions left, and when are we going to start the second session? So that I can. Hello. Yeah, yeah. Yeah, 2 o'clock, right? So do we still have how much time do we have now? We have another half an hour for me. Yeah, sure. Okay. So this was a basic introduction, and so today's topic was going to be on static and dynamic analysis. So let's first understand in this next half an hour. Let us start, get a small idea what is an FEA, what is FEA4, and what is static and dynamic analysis. Okay. So what is the difference between a static and a dynamic analysis? Can anyone give me a small clue? Anybody? Just as I just wanted to get an input so that we can go how deep we can go. Just want to get an idea of your frame of mind. If anybody can give me a small idea of if you know any difference, what is static analysis? You could have guessed from the whatever we've gone so far. You could have a small idea of what is a static analysis and what is a dynamic analysis. Anybody? Okay, let me start. Okay, so in just give me a second. Just, yeah, that's starting with the same load and apply a different intervals of time. Yes. Okay. So most people have this view that static is independent of time. Static analysis is independent of time. Now, static analysis is dependent of it's not independent of time. So what is static analysis is when you're doing static analysis, you're considering the load and the time taken, the frequency at which the load is applied is very large, or the time taken, to apply the load is very large. So these conditions are considered static analysis, doing static analysis, and when your load is applied over a very small time, and the frequency is very less, and there are inertial effects on your from the loads that you are applying, then you go to dynamic analysis. Before we go to any further, I would like to give you a small insight into what is the you. So I spoke so much about the software, the Similia, and the products that Similia gives, power of portfolio that we call it as. And what is the point of doing all these simulations? Okay, so what ABAQUS is a very finite element model. So what does a finite element method is? So what finite element analysis is? Uses finite element methods and numerical techniques and converts your physical problem into mathematical problems, and you find a solution for you. So here in the slide, you can see there's a physical connecting rod. This is your physical model. So it has to be discretization. So what is the process, or what is the need for doing discretization? So to uh, to understand that's what the finite element method is. So we have a model and we cut it into, this is a continuous part, right? So to do the analysis, we need to make it into smaller parts. So these are all using discretization method. So this model can be designed into elements and nodes. Okay, so here you can see elements. This is a tetrahedral. This is being meshed with a tetrahedral element. So here you can have element and nodes. So what are elements and nodes? So for doing that, after you, so what are nodes? Nodes are the points, where the all your for each element has nodes, and these nodes, so this is where all your stress data and the displacements are calculated and integrated. And then from this, I will do the finite element for using the finite element model, which is very mathematical model and can solve for given loads and boundary condition to arrive at the results. So here we can see a small example. Okay, so you have a small beam that is being pulled. So what is stress? Stress is normally load per area, right? So, and what is strain? Strain is change in length to the original length. And we have the Young's modulus. So from here, you can see the calculation. If you're doing a small calculation of a beam calculation, it can be done with a hand. So here, using the stress and strain, you get the Young's modulus. From that, you can get the load deflection relationship. And then, see, now you can consider this like a spring element. So this will have some because you're pulling the load, there will be some resistance given by the body here. So that resistance can be the stiffness, that is the stiffness of the part. So if we can rewrite this load deflection equation, that would be P equals to K into U. And this is the fundamental equation that's been going to be used to do the finite element analysis. So for the simple beam, you can do a normal stress for, you can calculate the stress and strain, and you can get the deflection and load parameters, shear stress parameters. But if a model is very complicated, like a casting component of engine block, for that you cannot apply simple technique, simple procedure. So for that you need numerical. That's why we use numerical techniques like FEA. FEA is a numerical technique, the computer-based technique used to do the finite element analysis. You go to the previous slide. This is the point of doing a finite element analysis. And so hope you're all having a bit of clarity about the FEA. Would you like me to repeat? Anybody? So shall I continue? Yeah. spoke. One second. Just give me a second. Just let me get the slides in order. So, till now we spoke about simple static analysis and how does it work? So, just hold on a second. We spoke about static analysis and what is the need for doing analysis. So now let us come to what is dynamic analysis. So when do we consider a problem to be dynamic? A problem we consider to be dynamic when there are due to the force that you apply, the internal forces develop, and there is internal resistance, and the inertial forces generated, and there is structural acceleration. So when to the force that you applied, when they have inertial forces and structural masses and acceleration, then you consider it as a dynamic analysis. Just here you can see for static equilibrium, there is no imbalance between the internal forces that you applied and the external forces. So when you go P minus I, if you P is your load that you applied and I is your internal forces that are generated to that. Here in the first equation you see, as I told you before, F equals to K into D. So here it's the same form and it is equals to 0. Okay, and but when you're coming to dynamic analysis, not only we have to consider the inertial effects, the damping effects, all this come into picture. So this is the here you can see the linear dynamic analysis. This is a basic equation which you need to keep in mind for the basic linear dynamic analysis, where here you can see in this equation, let me go through the parts of the equation. Here the first is the mass component system matrix, mass system matrix, and then here this is C comes into your damping due to the. So what does damping mean? So whenever you're in dynamic event, after application of the force due to the internal resistance, there will be damping from the component. So right, so you need to have that component, and then K is a system stiffness matrix that I've shown you before how to calculate the stiffness. So with a static problem, it would be simple, P is equals to K into U. But when it comes to dynamic problems, because of the inertial effect, the inertial, how is the inertia caused? Inertia is, to consider the inertial effect, we need the mass matrix and the damping matrix. So other issues to be considered while doing a dynamic response analysis is conservation of energy and damping and how the loads applied. So if the load is applied in very fast, then you consider the dynamic analysis. So here you can see, if you don't have this in this picture here, where the load P is applied, and if you're applying a load, and This is the stiffness of the component. So forget about this damper. Without this, we can consider this as a simple static problem. But when the effect of damping comes into the picture and the load is very fast, then we have the participation of mass as well. We consider it as a dynamic problem. So dynamic solutions can be when the load is very instantaneous, okay, then you go to dynamic problem. So for example, the spinning of rotor is a transient dynamic effect because it's getting the rotor is getting accelerated from 0 to 10 seconds, and the RPM is increasing very fast. Okay, so when we consider this question, can we consider this as a static analysis? You can say that, but due to the stress induced due to the initial rotation or the acceleration, those can be considering those two steps can be considered as a first step due to the centrifugal the stresses coming from the centrifugal force of the rotor and due to the initial rotation speed. Those stresses can be considered as a static analysis, and those two can be combined after that. And during the acceleration period, when in this period when the time is very small and the effect of this load is very high, that becomes a dynamic problem. So how we can consider first we can do a static analysis on this, do getting the loads, and then we can do the dynamic analysis. So in the different types of dynamic analysis that can be done. Types of dynamic analysis, you can have free vibration analysis with natural frequency, that is normal linear dynamic analysis, and if you consider non-linear, then you go to transient or forced vibration. Those come under the non-linear dynamic analysis. Uh, any questions so far? Understanding static and dynamic loading. Hello. Sure. I'm sorry, just give me a second. So I'm going to give one more brief introduction of ABAQUS FEA. So as we spoke before, it has both the pre-processing. You can include the modes like you can import third-party CAD models, and it has a very robust analysis. You can do both standard and explicit analysis, and then it has a very good visualization post-processing. Okay, and then so if you go to, I will show you the ABAQUS CAE. So here you can see this is, let me start on how to start an ABAQUS window. If you go to your Windows and go to programming and go to your Dassault systems, establish products. we double click, and this is how your ABAQUS starts as. Once you double click it, it will take some time to open up. Meanwhile, let's have the, as it's shown before in the PPT, let's go through the module or the workflow. So when you open an ABAQUS, you can see it's very easy to follow. There's a workflow which you can follow, do a small analysis, a small aligned analysis. So I will go through the workflow once again. So we have the first initial module, which is a part module, where you can create the geometries, and next we will have the property module where you can assign the, define the materials and define additional regions. Like if you're doing a beam element, you can create, define the section there, assign the section, and then you can assemble if you have multiple parts. And third would be your assembly module, where you can position the instances accordingly, multiple parts, you can assemble them. And then fourth would be a step where you will be giving the, where you're giving the input of it's going to be static analysis or dynamic analysis, or this is step module. You do the analysis step, and you can view the what are the output requests that you want. You want stress results, you want the displacement results, and then we have interaction, where you can view the define contacts and contact constraints, and then we have loads and boundary condition, and we have a loads module where you can find loads and boundary condition for the part, and then we have the meshing. As I told you before, ABAQUS CAE has very robust, meshing inbuilt into it. So you can, if it's a small part here, you can see very good hex mesh can be, dominant hex mesh can be derived from that. And then you can give and then submit the job and do the analysis in the same ABAQUS CAE itself. And then we have the visualization. And let's go to the, so these are the different ways as I shown you before on opening the, you can go to the command prompt and open the ABAQUS CAE, or we can go to start menu and open the ABAQUS from there, drop down, go to the search systems India, and we have the drop down, and you can open the ABAQUS CAE from there, or you can double click on the .cae file and open the ABAQUS. So that's all for this session. Okay. And shall we come back and do the workshop? And we'll have a workshop on having small static analysis and then doing the dynamic analysis, and we'll do a natural frequency model analysis as well. Okay. Shall we? Is it okay? Hello? Hello? Am I audible? Yeah, sure. So, shall we take a break now and continue later? And when we come back, we can have the workshop. Yeah? Yeah. Okay. Okay. Yeah. Short to PM. We'll start there. Okay. Okay. Let's have a break.
Okay, sir. Sir, one doubt. Sir, is there an attendance for this class? Okay, sir. Okay, sir.